Hi guys, this is Dr. G here, and in this video we are going to talk about two of the gas laws. So in this video we will talk about Avogadro's law and the ideal gas law. And in a previous video we have already discussed three different gas laws called Charles law, Boyle's law, and Gay-Lussac's law. So if you want, you may watch the previous video in order to understand this video better, okay? All right, so let's get to the Avogadro's law. So basically, Avogadro's law is somewhat similar to the three other laws that we discussed earlier, which are known as Boyle's law, Charles' law, and Gay-Lussac's law. If you remember those previous three laws, okay, in those three laws we kept two of the four gas parameters constant. Okay, so if you don't remember what are the four gas parameters, those parameters are pressure, volume, temperature, and the amounts. Okay, so these are the four gas parameters, and the three laws that we already discussed kept two of the four parameters constant. And of course, in all those three laws, Boyle's law, Charles' law, and Gay-Lussac's law, we always kept the amount of a gas constant and also one other parameter constant. But in this Avogadro's law, we are not going to keep the amount of a gas constant. Instead, we are going to keep the temperature and the pressure as a constant. So in when talking about the Avogadro's law, okay, we are going to keep two of the four gas parameters constant, and those two parameters are going to be pressure and temperature. So for you to apply Avogadro's law into a gas sample, you have to have pressure and temperature constant. Okay, pressure and temperature constant. So the only other two parameters that are remaining are going to be volume and the amount. Okay, so those are the two parameters that we are interested in when talking about the Avogadro's law. Okay, so as you may understand, usually if the pressure and temperature is constant, if the pressure and temperature are constant, okay, usually the amount of gas that you have is proportional to the volume of gas. In other words, if you increase the number of gas molecules that you have in a container, by increasing the number of gas molecules, we increase the number of collisions between the container wall and the gas molecules. So therefore, if you want to keep the pressure constant, the container has to expand. So basically, volume is proportional to the amount of gas, so the number of molecules of gas. Okay, so V is proportional to N. Okay, V is proportional to N according to Avogadro's law. But here's the thing, I mean, we want to replace the proportionality sign with an equal sign. So in order to do that, we replace the proportional sign with an equal sign, and also it comes with a constant. So K here is a constant. Okay, K here is a constant. So you can take N to the other side by cross multiplication. So you get a ratio between volume and the number of moles as a constant. So just like the previous three gas laws, okay, but in here we get the ratio between the volume and the amount of a gas a constant at constant pressure and temperatures. So we can rewrite this relationship in an equation format for two different situations, such as V1 N1 equals V2 N2. Okay, so this right here is the equation for Avogadro's law. Okay, and also what is 1 and 2? They are two different situations for a gas sample. Okay, they are two different situations. So you can say initial and final state of a gas. Okay, keeping that in mind, let's go back to our lecture note. So this right here is the equation that we just derived. Okay, v1 divided by n1 equals v2 divided by n2. This right here is known as Avogadro's law. But if you want to apply the Avogadro's law, remember you have to always have the pressure and the amount and the temperature of a gas constant. Pressure and the temperature should always be constant. Okay, all right. So according to Avogadro's law, okay, the volume of a gas is directly proportional to the number of gas molecules. Increasing the number of gas molecules basically increase the number of collisions that you have between the wall and the gas molecule. So if you want to keep the pressure a constant, the volume must increase. So we discussed all these things, right? So I want you to take a minute and then see if you could try this sample problem or example question from Avogadro's law. Okay, so I want you to pause the video and try it by yourself. In a second, I will give you the answer. All right, so in this sample problem or in this example, there is a male athlete in a kinesiology research study has lung volume of 6.15 liters. So we have V1, okay, during a deep inhalation. At this volume, his lung contains 0.2554 moles. So that will be our N1. This right here is our N1. Okay, so we know V1 and N1. Okay, and during exhalation, the volume of course is decreased. Okay, so this will be V2. So how many molecules of gas does the athlete exhale during the exhalation? Okay, so we have to basically first calculate N2. Okay, so that is the remaining lung volume. Okay, and then with that we can use N1 and V2, N1 and N2 terms, and we can get the difference and calculate the number of gas molecules the athlete has exhaled. Okay, this is what we need to do in this worked example. So let's try this. Of course, you have to assume that it is at constant temperature and pressure. Otherwise, you couldn't use the Avogadro's law. Okay. All right. So we use the Avogadro's law, which is basically V1 divided by N1 equals V2 divided by N2, and then we have to figure out N2. So we need to rewrite Avogadro's law as a function of N2. Okay, and then you substitute V2, V1 and N1. Okay, you get the number of moles, okay, which is the remaining number of moles of gas in the lung. Okay, and then exhaled moles is basically equal to what? N1 minus N2. Okay, N1 minus N2, which is 0.149 moles. 0.149 moles. Okay, this is how you do a simple calculation. Okay, just like what we did in the previous three gas laws. All right, so if you need more practice, you can try the other practice problem. Okay, and let me know if you have any questions. Okay, but in the next slide we are going to talk about the ideal gas law. Okay, so this is basically the mother of all gas laws, so you can say this is the more complicated gas law out of all. Why? Because the four gas laws that we discussed before, the Boyle's law, Charles' law, Avogadro's law and Gay-Lussac's law, these four laws always kept two of the four gas factors constant. Okay, so they always kept two of the four factors constant. Okay, but in this ideal gas law you don't have to keep two of the four factors constant. Okay, if you know three of the four factors, okay, if you know three of these four gas factors, okay, or the three of these four properties of a gas, you can figure out the unknown. Okay, we can figure out the unknown. To derive this ideal gas law, okay, you can use Boyle's law, Charles' law and Avogadro's law. Okay, so basically according to Boyle's law, volume is inversely proportional to pressure, and according to Charles' law, volume is proportional to temperature, and according to Avogadro's law, volume is proportional to the number of molecules. of a gas. So basically all these three laws have volume incorporated into it. So basically volume is proportional to temperature and the amount of a gas, but it is inversely proportional to the pressure of a gas. So you can combine all these three laws and you can say that volume is basically proportional to temperature and the amount of a gas, but it is inversely proportional to pressure. So you can basically build a more advanced relationship out of these three laws. Okay, but here's the thing: if you wanna get rid of the proportionality sign, if you wanna get rid of the proportionality sign, you can do that by bringing in a constant. So basically, if you do that, it will be V equals, okay, N T and the proportionality constant, okay, divided by P. So R right here is our proportionality constant, but we call it the ideal gas law constant. We call R the ideal gas law constant. So this basically is your ideal gas law. V equals N times T times R divided by P. Of course, you can rearrange this equation. By taking P to the other side. So the ideal gas law is commonly written as PV equals nRT. Once again, guys, you already know these terms that are associated with the ideal gas law. P stands for pressure, V stands for volume, N stands for the moles of gas, T stands for temperature in Kelvin, and then R is the ideal gas law constant. So I want you to remember this equation. Okay, it is very important that you remember this equation. All right. Sometimes, of course, you may not know the number of moles. Okay, instead people might give you the mass of a gas. Okay, if that happens, what you do is you basically use the equation n equals you basically use the equation n equals mass divided by molar mass. Okay, so you can substitute n with m over m. Okay, this m, the lowercase m, stands for the mass in grams, and uppercase m stands for molar mass. Okay, so if you don't know the number of moles and if you know the mass, you can easily figure out the number of moles using n equals m over m equation. Okay, so sometimes you can define this ideal gas law as PV equals mass divided by molar mass, okay, RT, depending on the terms that you know. Okay, so this is ideal gas law. All right. Okay, so the other important thing to remember is the ideal gas law constant. Okay, most of the times people will remember this term because it is common not to give this constant in the exams because most people already know it. Okay, but I tend to give this constant, but in case if I don't give you this ideal gas law constant in the exam, remember the constant. Okay, so the ideal gas law constant is 0.0821 liters atm per mole per Kelvin. Okay, so this is the ideal gas law constant. You might want to remember that constant. All right, so even though ideal gas law has all four properties of a gas incorporated into it, by keeping two of the four properties constant, you can obtain the three laws: Boyle's law, Charles' law, and Avogadro's law. But of course, okay, ideal gas law allows us to find one of the variables out of the four if you know the other three remaining variables. Okay, that is the more important thing about ideal gas law. And here is a practice problem from ideal gas law. Okay, so I want you to pause the video now and see if you could try this by yourself. Okay, so in this sample problem, you already know the number of moles, you know the pressure, you know the temperature in Kelvin. Okay, so only thing that you don't know is the volume. This is the only thing that you don't know. Okay, so you can rewrite the equation. This is the ideal gas law, okay, nRT. So you can rewrite this equation as a function of V, because V is the unknown, okay. So nRT divided by P, okay. This will be your um, rearranged equation, okay, and plug the numbers and you will get the answer. So you already know N, you know T, you know P, and R is also known, okay. So you can figure out V. You can easily figure out V, okay, and here is your answer. Please feel free to pause the video and write down the answer if necessary. Okay, so you will calculate the volume using the equation, which is going to be 15.9 liters. 15.9 liters. Okay. All right. So there's another practice problem at the end of this slide. If you wanna try that example at home, okay. Let me know if you have any questions, okay. And in the next slide, I have another sample problem for you, okay. And you might want to pause the video and try this by yourself and then compare your answers, okay. Compare your answers. All right. So I hope you calculated the answer, but this is how you solve it. All right. Please feel free to pause the video and double check your answer. Okay, double check your answer. The very last thing that we are going to talk about in this lecture note are the standard conditions. So these standard conditions are basically conditions that a set of scientists agreed to, especially the conditions or constant conditions for pressure, temperature, and the amount of a gas. Okay, so basically chemists have agreed to a set of standard conditions for temperature, pressure, and the amount, mainly because it helps the comparison of different gases. Okay, so these standard conditions are also known as STP in short. Okay, you might have already heard about STP. That means standard temperature and pressure. Okay, standard temperature and pressure. So in gas chemistry, okay, standard pressure is 180 m, standard temperature is 0 degrees Celsius, or of course 273 Kelvin. Okay, so these are the standard conditions, and the standard amount is of course 1 mole of a gas. So basically, by using these three conditions, 180 m, 273 Kelvin, and 1 mole of a gas, you can calculate the standard volume. You can basically calculate this standard volume. Okay, so if you plug everything that you know into the ideal gas law, okay, the volume you get for a gas is actually 22.4. Okay, this 22.4 liters is actually known as standard volume of a gas. And remember, the standard volume of a gas is defined or obtained by using the pressure, temperature, and the amount of a gas. So basically, the type of a gas is not important for the volume, the standard volume or the molar volume of a gas. Okay, so basically this standard volume has 1 mole of gas. So if you take 1 mole of any gas, okay, regardless of the type of gas, if you take 1 mole of a gas, it will have a volume of 22.4 liters. 22.4 liters. Okay, so 22.4 liters is also known as standard volume, or you can say molar volume of a gas. With that, I'm going to conclude this video. So I hope that you guys understood the two laws that we discussed in this lecture series, okay, which is basically Avogadro's law and ideal gas law. Please remember that I have a separate video for Boyle's law, Charles' law, and Gay-Lussac's law if you want further clarification. So let me know if you have any questions, okay? You guys have a good one. Take care.